Welcome to Programming in Modern C++. We are in week 4 and we are going to discuss module 17. We have in the last module discussed about static data members and member functions and singleton pattern. We will discuss the concept of friend function and class, which is related, but is a different, and this is kind of a very tricky feature that I am going to discuss in this module today. This is outline, and let us talk about friend function. So, let me, before getting into the definition, let me just start with an example. Let us say I have a class, my class, right, and I am creating an object for that, and I have defined a global function display, which takes a reference, constant reference to an object of my class, and then it tries to display the data. So, if I invoke display with this object that I have created, what do I expect to see? Display is a global function, it is a non-member. So, any access to private data in display by our information hiding principle is prohibited, right. So, the compiler says my class : data cannot access the private member declared in my class. So, this code will not compile. Understood. This is what we have learnt about the private access specifier. Now, I do a small change. I introduce this line inside the class, where I put the signature of the global function and precede it by a keyword friend. Rest of the code, nothing is changed. Now, it is perfectly fine. What is happening is display is still a non-member function. Display gets the reference to an object of this class. Display is trying to access private data. Now, this is where I had an error in the global function case on the left. In this case, since I have called it a friend, I know that my class is saying that everything is everything is private and not exposed to anyone else, except for someone who is my friend. You know, friendship we all know. Friendship is, you know, the members of a family get into the house. The public on the road is outside, cannot get into the house, but if I have a friend, I welcome the friend to my house, it is my prerogative, right. So, it is exactly the same thing. So, my class has said that this function display, which takes constant reference to my class and returns nothing, is a friend. So, it is allowed to access the private members of the class. That is basically the idea of the friend function, and so you can see that friend is actually a way to selectively break the encapsulation that we have built up with so much of care, and why we do that will become clear soon. So, by definition it is a friend function of a class has access to private. In public everybody has an access, so does this friend function. It has access to private and protected members of the class. Protected we have still not discussed, we will come in when we do inheritance, but know that there is another type of access specification. So, clearly it breaks the encapsulation. The prototype must be included within the scope of the class, so that the class is saying that I know that this function is my friend, but it is not a part of this class. So, its name is not qualified, it is a function outside of the class. So, it is just saying, I mean, a friend does not become your family, right. Friend and family are different. Family also has an access, because they belong to the same group, but friend is someone who is not a part of that, but has a similar kind of access. So, the name is not qualified and it is not called with an invoking object, because it does not have a this pointer of this class, may have a this pointer of some other class, and a function can be declared a friend in more than one classes, not necessarily in only one class. What can be a friend function? A global function, an example that we have seen. Even the member function of one class can be a friend of another class. Member function of one class can be said to be a friend of another class. So, in that case, that function will require the this pointer of the class of which is the member function, but not the this pointer of the class of which it is friend, or it will not be scoped by that class. It will be scoped by the class in which it is a member function, or it could be a function template. We will talk more about that when we talk about template later. Just know that it could be a template. So, let us take an example. The example here is to be able to multiply a matrix with a vector, right. So, I have a vector class. Vector class, it has a constructor which does some arbitrary initialization. This initialization knows no meaning, I just initialize with something. It has a way to clear a vector, set it all to 0, and it has a way to display the vector. These are the member functions of vector. So, which tell you the status of the vector. And I have a matrix class which has, obviously the vector has private members, which is the vector array and the size. I am not using the vector component of STL, just giving you a simple example with array. Similarly, in matrix I have a 2-dimensional array and the 2 dimensions m and n. I have a constructor which does arbitrary initialization here. I have a function to show, that is display what is there in the matrix. Now, I want to multiply these two. So, I write a function here which takes a matrix and a vector. So, I multiply a matrix by a vector, what will get? I will get a vector, right. So, I create a vector v and that will get initialized with these things. So, I clear it, I make it all 0, that is my result vector that I want, right. And this is the code which is easy for you to see, that you go over and you keep on making the component wise multiplication going along the rows, columns, and you can get the v. Now, the issue here is this function needs to know the access the element here of matrix, which is private. It also needs to access the element E of the vector, which is private. So, the question is, now it needs to access the private members of vector as well as private members of matrix to be able to do the multiplication. Now, which means that this will have to be a member function. Now, member function of which one? For matrix, then it does not work for vector. For vector, then it does not work for matrix. So, that is where the concept of friend comes very handy. So, what I say that this is a global function, let it be a global function, it is not a part of anyone, but I include the prototype of that with a friend keyword in matrix, and I do the same thing in vector. So, vector says that prod function is my friend, matrix says prod function is my friend. Since vector says this, any access from PV to the private members will be permitted. Since matrix is a friend, any access from PM to the private members would be permitted, done, and this code will perfectly run. So, it is not that you will make a function friend at any point of time and kind of break the encapsulation, because you are actually breaking it. You are letting global functions, external functions to take access to the private data, which you have very carefully crafted in terms of your information hiding. But in such situations, you can judiciously use it to have a very nice solution. If you did not have this, then what you will need to do? You will need to do a lot of things. You will need to put a get on every member function, you will need to put a get on every member function of vector for matrix, lot of function calls will get involved, then they will have to be optimized by inlining and so on and so forth. But here you write a very clean code for doing all that. Right? So, if you have done that, then this is for you to basically try out. You can put all this code, execute and see that you are able to see the product done in a very nice way, very clean way, so to say, that the whole thing will get done. Another example, let us say we are building a data structure linked list. So, what does linked list involve? Linked list involves two kinds of classes, objects. One is the node, every node of the linked list, which must have some data, information and the link, at least one link. If it is doubly linked list, then it has two links, so on. So, I have a node class which has information, the data of that node, and this is a pointer to the next node. Right? So, this is the minimum that I need. I have a constructor based on that. Now, I need another class which is the list itself, which is the list of nodes. Right? So, I have a list class which actually has two pointers. One is so it is like this. I have say this is my list. So, this is my nodes and my list has two pointers, one is a head pointer, one is a tail pointer. Having the head pointer is important, tail pointer is just a matter of convenience, because if you want to append, it gets easier if you have the tail pointer, otherwise you will have to go all through the list. If you have to append, you need the head pointer. Right? So, I have a pair of node pointers. Right? Now, so what I have is a pair of classes which are interdependent. Right? So, you can easily see that list is making reference to node. Right? So, they are interdependent. Here I could have declared node before and then list. I have just chosen to do it this way, just to show you that when such things happen, this will give you an error, because it does not, compiler does not know what is node star. So, I have given a forward declaration for the node without specifying the details. Now, the question is, suppose I have to now display, write the display function on the list, that is, go over this list of nodes and display the values. So, display function will start with the node header, as long as it will keep on traversing by doing pointer next, pointer next, pointer next, and print the pointer data till you come to the last grounded pointer. You have to do this. Right. Now, the question is, this function display is semantically, logically a member function of list, because there is no sense of displaying a node as such. So, this is a member function of list, and it is trying to access the private data of node, again a violation. So, to allow that, what I do is I make this member function is list : display. I make that a friend of node. When I make it a friend of node, the compiler will allow this function to access the private data members or private member functions, here that is not there, private data members of the node class. Similarly, I have an append to do. I am given a node pointer and have to append it to the list. So, I put this, then I put tail pointer next as P and tail pointer next as tail. This will insert. Right. So, I have made this also a friend of node. It is not, you can say that this is not necessary, is it, or it is not. Why is it necessary? It is necessary because I need to manipulate the next pointer, which is a private data member of node. So, without that I will not be able to, without being a friend, I will not be able to allow that access. This will not compile. So, I also make this as a friend function. So, you can see the earlier example of vector matrix multiplication was using a global function to make friend of two classes. Here we are making the member functions of one class as friend of the other class, so that this can cross communicate in this manner. Right. So, these are typical situations where friend really can help you, and you can run this example to see. Now, as you can see, here we had two member functions which had to be friend of another class. In several situations there may be many member functions of a class which need to be friend of another class. So, in that case we have an added feature by which we can make a class as a whole a friend of another class. Right? So, it is like a family friend, where you do not say that individual member is a friend is one way of saying, but you say okay, Mr. Vardhan is our family friend, which includes that Mr. Vardhan is a friend, Mrs. Vardhan is a friend, their son is a friend, their daughter is a friend, their daughter-in-law is a friend, their son-in-law is a friend, the entire thing. So, similarly, so I say that friend class of a class in the similar manner has access to private and protected members of the class, breaks the encapsulation in the same way, and does not have a name which is qualified in this class. It is not a nested class. There is a concept of a nested class, again we have not done a class within a class. This is not that, you are just saying these are two independent classes. This class says that class is my friend. So, that class can have all kinds of private accesses, and it can be declared friend in one or more classes. What can be a friend? A class or a class template when we do template. So, we will rework on the previous example using this. So, all that we do is in the same linked list. Now, in the node class, I do not say that list : void is a friend function, list : append is a friend function. Rather, I say that the friend class list as a whole is a friend. So, right now class list has only two member functions other than the constructor, destructor, etc. If I add another member functions, I do not have to say that it is a friend of node, it will become a friend of node. If I add a prepend function, if I add a search function to the class list, they all will automatically become friend of the node, because the class as a whole is a friend. Right? So, this is just a kind of it is not only a syntactic sugar, I should say, but it is kind of a semantic sugar that you do, that you say that I have a concept of the friend's family, and the friend's family is a friend, everybody is a friend in that. Then linked list with iterator. What is an iterator? Iterator is like a for loop. You have any set of elements, it could be an array, it could be a linked list, so an iterator is something which has a starting point and it has an ending marker somewhere, starting point and ending, and from the starting to the end I keep on doing it. We have talked about forward iterator, reverse iterator, all that in the context of the STL as well. So, now we are seeing how to build that kind of an iterator. Okay. So, let us see. So, what we have the node class, the list class. So, this is the list class, this is the node class, other functions of that are not being highlighted, only I have only included append here. There could be several other functions, because the focus in this example is different. And then I have an iterator class, which has to iterate on the list. Right? So, what the iterator has to remember? It has to remember the list that it is iterating on. It has to know the list on which it is iterating. So, it has a list pointer, and while it is iterating, it is a list like this, right. It is a list like this. This is the list, the header. Then after having seen this node, I will need to go to the next node, then I will need to go to the next node, then I will need to go to the next node. So, I have a marker that keeps on traversing. So, I need a node pointer which says which is the current node. Right? This is the basic information data of the iterator. Then what are the things you will need to do? You will have to initialize, that is, tell the iterator that this is the list on which you will iterate, that is the initialization. Right? See, that is different from the construction of the iterator. I can construct the iterator once and use it to traverse multiple lists. Constructor, all that it has to do is set the node and the list to null, but then I do a begin to say that this is where my iteration starts for this particular list. I need an end to check where to stop. That the list could have 20,000 elements and I want to iterate for 1,000 only. Right? So, I will have some condition, or it may be the end of the list, some condition to check when to stop the iteration. So, end is a function in the iterator. If I call that, it checks if the end has arrived. If the end has arrived, it will stop. Here I have modeled assuming that it goes up to the end of the list. Then at any point what I need, once I am done with visiting one node, I need to go to the next node. Once I am done with that, I need to go to the next node and so on. So, I need a next function which takes me to the next node on the list, that is the next member function here. Then when I am at a node, I will need to get the data of that node, because otherwise why am I iterating? Because I want that information of the node, right. So, these 4 functions, begin, end, next and data, form the interface for an iterator. These 2 data members form the implementation of the data member of the iterator, right. So, now let us try to write these functions. I want to write begin. So, I have list pointer passed to it. So, the list member of the iterator will be set to L, node member will have to be set to L pointer head, the first node. Right. So, if I have to do that, where is L pointer head? L pointer head is here, node star head, right. So, it is a private data member of the list class. I will not be able to use it, access it. What I do? I make class iterator as a friend. I have made the class iterator as a friend. So, now it can freely use. Think about the end. All that end needs to decide is your current node is null. It does not need to look into list or node classes, but as a ensemble of list class, it has become friend of list, as an ensemble of the iterator class, which is a friend of list, it is also become a friend of this member function, also become a friend of. In the next one, I need to access node pointer next, which is a private data of the node class. So, iterator must be a friend of node. So, iterator is a friend of list as well as a friend of node, and friend of node is needed for these two member functions of iterator, and friend of list is needed for this one. Similarly, I have an append function which I have seen before, which needs that list is a friend of node. So, you can see that list has a friend which is iterator, and node has two friend classes, one is a list, another is a iterator. And with that, I can write this whole iteration process in a very compact manner. This is a list, I have created some arbitrary nodes, I have appended them to this list, which I did in the previous example also, and then I do a begin, that is initialization, which sets everything here. Then I check if the end has been reached, if not, I will continue. What I will do in the continuation? I will print the data, the information of that node, and then I will go to the next node. See, the beauty of this whole design is, and that is the beauty of iterator, and again it is a design pattern, and we will talk about that more. The beauty of this design is it does not need to know what is there in the list, what is there in the node, all that, none of those details, but this simple code is like a simple for loop which will always work, right. And to be able to make such things work, we need the friend class friend function. So, the basic properties of friend, if you must remember, is first thing is friendship is neither commutative nor transitive. That is, if A is a friend of B, B is not necessarily a friend of A, right. So, node has said that the list is its friend, but by this node does not become a friend of list. If this is to be said, this is to be said explicitly. Second is not transitive, that is, if A is a friend of B and B is a friend of C, does not mean that A is a friend of C, right? None of these will hold. In terms of visibility and encapsulation, as you can see, public visible to everyone, protected as we will see subsequently is visible to the class as well as to its subclasses, private visible to only the class itself, friend, anything which is a friend will have the visibility like the private. Right. So, but it is an external function or a global function or a member function or a template or any class or a class template. So, the friend will break the encapsulation, it will break the data hiding property, and therefore, it must be used very judiciously. And just few scenarios and variants of that are where you use friend, like when the function needs to access the internals of two classes, two independent classes, as we have seen, matrix and vector. When one class is built on top of the other, there is a node, on top of that you have list, on top of that you have iterator, right, you have a 3-stage hierarchy. So, you need to go deep and see, and that visibility requires friend to be used. And we will show you some examples of specific streaming operators and so on, which make use of friend in a very specific way, and please keep those in mind and do not use the friend feature arbitrarily in your design. So, here the whole of friend is summarized. For friend functions particularly, we have I have given a comparison with the static and non-static member functions. You have, if you have understood the basic concept, these all will become like obvious for you, but just they are summarized so that you can refer to them, and in case you have a confusion that, well, what happens in this case, how does the friend behave and how does the static function behave or a non-static member function behave, you can refer to this comparative chart. So, that brings us to the end of this module, where we have introduced the notion of friend function and friend class, and discussed several very specific examples, and you will see that these examples keep on coming, and even in your placement interviews and so on, it is very likely that you may be asked one of these some of these questions, because they are very favorite of various most people. And just remember that friend introduces visibility hole by breaking the encapsulation. It must be used with care, and that is another point that most of the time interviewers would like to know, that if it does so, then why do you still have friend, or do you use friend in such a situation, and so on. You have to study and give response in a very judicious manner. Thank you very much for your patience, and see you in the next module.